In this video, we'll learn how to estimate the parameters applied in the nested Logit models. Now let's start with a simple example with 2 dimensions. Here we will recall the mode destination problem. We define the probability of selecting the mode destination combination D and M for this problem. And the utility for this problem is defined as summation of 3 deterministic terms and 2 random terms. This figure shows the nesting structure for the 2-dimensional problem. Here we assume that the random terms for the mode is always 0. From our previous analysis, we get the expression of the marginal distribution, and it contains the log sum term, which will represent the utility of all the modes with respect to the destination D. Also, we derive the conditional probability of the mode M given the destination D. Then with the Bayes theorem, we can find out the joint probability as the product of the conditional probability and the marginal probability. Similar to the MNL model, we assume that there is a linear relationship between the attributes and the deterministic utility. That is Vm equal to beta m times xm. Here, beta m is the coefficient and xm is the attribute for the mode m. And similarly, we will have the expression for Vd and Vdm. For the model estimation, usually we will call the likelihood function. It will represent the products of the probabilities for each individual to make the decision. Here, the term ydmn will be 1 if the individual n choose the combination of d and m, otherwise it's 0. In this likelihood function, we can apply the Bayes theorem to replace the joint probability with the conditional probability and marginal probability. In addition, we can apply the log transformation for the likelihood function and get the log likelihood function to simplify the estimation. With this log transformation, we will replace the product operation with the summation operation. And we can also divide the log likelihood function into 2 terms. The first term is only related to the conditional probability, and the second one is only related to the marginal probability. Then the maximization of the log likelihood can become the maximization problem of both term 1 and term 2. First, for the first term, we know the expression of the conditional probability, and we can apply this expression in the equation. Also, we have the expression of the marginal probability. And then we will have the full expression of the log likelihood function. Also, we say that the deterministic term are the linear functions of the attributes, and then we can replace those deterministic terms with the linear expression. And with this kind of log likelihood function, we can try to complete the estimation of the coefficients including beta m, beta dm, and beta d. In this case, we also need to estimate the values of mu m and mu d. Here are the steps for us to complete the estimation. First, we need to estimate mu m times beta m and mu m times beta dm using the conditional choice model, the probability of m given d. And here we assume that mu m is 1. Then the estimate value of mu m times beta m will just be beta m, and mu m times beta dm will just be beta dm. The estimated value beta m hat and beta dm hat will be captured by the mu m beta m and mu m beta dm. The estimation process is actually exactly the same to the estimation of the MNL model, but here in the estimation, you need to carefully select the data set which will fit to the conditional probability. The second step, we will consider using the estimated beta m and beta dm hash to compute the estimate value of the log sum term. We say that it's a VDN hat to represent the VDN. For VDN hat, we can apply the equation here to complete the estimation. In this kind of estimation, we assume that mu m is 1, that comes from the first step, and also we already captured the estimate value of beta m hat and beta dm hat. Then we will have the estimated log sum term. The log sum term is applied in the second term with respect to the marginal probability to complete the estimation of mu d and beta d. In the third step, we say that the estimated log sum term is an independent variable applied in the marginal choice model, and we can use the second term to estimate mu d times beta d and also mu d hat. The estimation process is also the same to the MNL model. You can recall the detailed steps for the MNL model estimation. Now the most critical part is how can we identify the estimated log sum term in this estimation, and what's the meanings of this term in the model. So let's go to now let's see one simple example about how the estimated log sum term is applied for the marginal probability. The table here shows the observations about the attributes related to the destination for each individual. It contains JD attributes, and all of them will be applied for the estimation of the coefficients of beta d. But with the estimated log sum term, which will comes from the first two steps, we can get an additional attributes for each individual, and these attributes is actually applied in the marginal probability, and you will see that it will becomes one additional term in this linear equation. And with this kind of format, we can apply exactly the same MNL estimation to get the values of the mu d beta d and mu d. Then with this kind of estimated value of mu d beta d and mu d, we are able to find out the value of mu d hat. That's the estimated value for mu d, which is just the mu d times beta d over mu d hat. Now let's summarize the steps for us to complete the two-dimensional nested Logit model estimation. First, we have the probability of selecting a mode destination combination D and M, and we define the utility for DM with respect to 3 deterministic terms and 2 random terms. And we define that deterministic terms are linear functions of the attributes. We also derive the formula for the probability of taking D and M. And also in this probability, we have the log sum term. So for the model estimation in the first step, we assume that mu m is 1 and estimate beta m hat and beta dm hat from the normal model estimation for the MNL model. Second, we will estimate the values for the log sum term for each individual. Third, we will estimate the beta d hat and mu d hat for the second term comes from the marginal probability. And that's the entire process for us to complete the two-dimensional nested logic model. Now let's see how the model estimation can be extended to 3 dimensions. Here we will recall the mode destination route choice problem. The utility of each combination, DMR, is defined in this equation. It contains 7 deterministic terms and 3 random terms. From our previous analysis, we get the conditional probability of R given D and M, the conditional probability of mode M given the destination D, and the marginal probability. For the last 2 probabilities, there are 2 log sum terms, and they contains 2 additional variables, mu R and mu M. And in the model estimation, we also need to find out the value of mu R and mu M. From Bayes' theorem, we can find that the probability of DMR, which is the joint probability, is the product of the conditional probability R given D and M, the conditional probability of M given D, and the marginal probability D. In addition, we assume that all the 7 deterministic utility are linear functions of their own attributes. And here, the coefficients from the linear relation are the parameters we have to capture from the model estimation. Similar to the previous analysis, we will call the likelihood function and maximize the likelihood function for the model estimation. Here, the variable ydmrn equal to 1 if the individual n choose the combination of dmr, otherwise it's 0. We also know that the joint probability would be the products of the conditional probabilities and the marginal probability, so we can replace the joint probability with the 3 probabilities. And we also apply the log transformation for the likelihood function and change the product operations into summation operations. And then the log likelihood function can be divided into 3 terms. In that sense, the maximization of the log likelihood function can become the maximization of all the 3 terms. For the first term, it's only related to the conditional probability of R given dr, and we have the expression for this conditional probability. The second one is only related to the conditional probability of M given D. We also have the expression about the M given D. And the last one is the marginal probability for destination D, which we already derived the expression. And this will be the full expression about the log likelihood function for the 3-dimensional nested logic model. Now for the model estimation. In the first step, we will estimate mu R times beta R, mu R times beta dr, mu R times beta mr, and mu R times beta dmr using the conditional probability R given D and M. Here we assume that mu R is 1, and then we can record the regular MNL model estimation to get the estimate values for beta R, beta dr, beta MR, and beta DMR. In the second step, we apply the estimated values of beta R, beta DR, beta MR, and beta DMR to compute the first log sum term, VDMN, and this would be the expression for the log sum term. In this expression, we assume that mu R is 1 from the first step. Then we will have the additional term VDM for the third step. In the third step, we will use the VDM as an independent variable in the conditional choice model, the probability of M given the destination D. And then we can estimate the variables mu M times beta M, mu M times beta DM, and mu M. In that sense, we can also get the value of beta M hat and beta DM hat by using these two equations. In the first step, we will apply mu M hat, beta M hat, beta DM hat, and the estimated log sum term VDMN to compute the second log sum term, that is VDN hat. The estimation of VDN hat can be completed by this equation. We have all the values estimated from the previous step. In the last step, we will apply the estimated log sum term VDN hat as an independent variable in the marginal choice model and apply the regular MNL model estimation to get the values of the two parameters mu d times beta d and mu d hat. Also, with these two estimated parameters, we can find out the value of beta d hat as mu d times beta d over mu d hat. That's all about the estimation of nested Logit model. Actually, this kind of method can be extended to higher dimensions. To conduct the higher dimension estimation, you need to find out the conditional probability from lower levels to higher levels, and in each step you need to estimate the log sum term from lower level to higher level and apply the log sum term in the next level and utilize the regular MNL model estimation method to find out the parameters in that level. In the next lecture, we're gonna talk about multinomial probability model. It's also applied to deal with the same problem to the nested Logit model.